So our today's topic is change of order of integration. So good morning class. Myself PRIYANKA GODARA, Maths Optional Faculty, Plutus IAS. So our today's topic is change of order of integration. We have done multiple integration a lot of times. But what happens, sometimes it becomes very tricky to solve one of the integral or other. So if we have the limits that are constant of the into double integrals, then we can exchange the limits or order of the limit. But if one of the limit is some function of the other, say limit of y is function of x or limit of x is function of y, then it is not possible to change the order of the limit directly, and at that time we have to follow some of the procedure, and most of the time I have seen that students face difficulty in changing the order of integration. But this is going to be very smooth. I'll teach you how to change the order of integration of different integrals in the double integral. What happens, suppose this is sum of the function f of xy, and we have to do its integration with respect to dx as well as dy, that is double integration. And if it is the double integration, then here we would have limit of x and we have limit of y. If these limits, say x ranges from a to b and y ranges from c to d, if these are constant, then you can easily interchange these limits, that x can be written as outside, limit of x have been written outside, and then limit of y is equal to c to d, f of x y dx dy. But it is not possible to change these limits if we have, say, limit of x are some function of y only, that is if we have f x y inside dx dy, then take this some other function, say g of x in h of x, g of y, function of x would be in the function of x would be in the function of y, and y has some of the limit, say a and b. So if we have these kind of limit, that limit of x depends upon y variable, or limits of x are in the some function of y, then it is not possible to interchange that. Then what will you draw? You have to follow some of the procedure, and the procedure itself says that whenever you have these limits, first your step should be draw the region of limits. That is, whatever limit is given to you, try to draw that limit. And if always remember, if the function is x is x, then if the limit of x are in the function of y, then the function is provided as in horizontal strips. As provided in horizontal, this is known as horizontal strip. And if you want to change the limit order of the limit or order of integration, then you are required to change this horizontal strip into vertical strip, and then accordingly you have to take the limits of the function. How would you change? Let's see by some of the example, and that's how you are going to learn how to change the order of integration. So one of the famous question, let me write, is change the order of integration. Change the order of integration in integral I, say this is I, which is given as double integral, where limit is provided with, first limit is 0 to 4a and second limit is x square by 4a to 2 root ax, 0 to 4a, and then x square by 4a to 2 root ax, right? And the function they have provided is dy dx. You don't have any function, just you have to double integrate these limit dy dx. Now how would you realize that which limit belongs to which things? Since these are limits in the function of x, so these limits would belong to y, that is they are limit of y. Y ranges from y is equal to x square by 4a to y up, and upper limit is y is equal to 2 root ax, that is y is equal to this, and these are limits of x, right? So first thing I told you is you have to draw the region of the limits, both the limits upper bound as well as lower bound. So first write the limit they have provided to you, that is limit is 0 less than x less than 4a, and then limit of y ranges from lower limit is x square by 4a and upper limit is 2 root ax. What will we do? We will try to draw this region, and since they have provided as the limit of y, so this the region that they have provided would be in the vertical strip, and our work would be to change this into horizontal strip, and then accordingly take the limit for first x, and then we need to take the limit of y. So how would you change? First we need to draw, and you need to, let's draw it into two-dimensional plane. Because two equation we have. This is x ranges from 0 to 4a. This line is, let me change the pen. This line is x is equal to 0. X is equal to 0 is nothing but y-axis, right? And then you need to draw x is equal to 4a. This line is, there must be somewhere 4a, comma 0, and this line is x is equal to 4a, that is x remains constant, which is always 4a, and y keep on changing. Then you need to draw another line, which is this one. Okay, great. But then first we will draw this one. What is this? X square by 4a is equal to y, and that is x square is equal to 4ay. What is this? This is standard equation of parabola, right? And which parabola is this? This one is vertical. Excuse me. This one is vertical parabola, that is vertically upward. How would you find out that? Because the powers of x are even, so it would be symmetric about y-axis, and it passes through 0, 0. So our parabola is this one, right? This is the parabola, and again you have, this is the second equation which says that y is equal to 2 root ax, right? And how would you find out this? They are saying, now square both sides, that would be y square is equal to 4ax, and now this is horizontal parabola, and this would be like this. Right, these lines we will require. So upper parabola is, this parabola is x square is equal to 4ay, and the lower one is y square is equal to 4ax. Now we need to find out their intersection. How would you find out the intersection? This is one of the equation. This is the second equation. Find out x from here and put this in that equation. So x from here is y square by 4a, and this y square by 4a from here, x would be y raised to power 4 divided by 4a square, 4a whole square is equal to 4ay. So this is y raised to power 4 is equal to 4a cube y, and I can take all the term on the one side and then y common. Keeping y common, we have y cube minus 4a cube, and this is equal to 0. So we have two values of y, that is y is equal to 0 and y is equal to 4a. When y is equal to 0, from this equation we get x is equal to 0, and when y is equal to 4a, we have x is equal to 4a. So we got two point of intersection, and these are 0, 0 and 4a comma 4a. So this is 0, 0, that is origin, and this point is 4a, 4a, and this line is also 4a, 0. So this line also passes through the intersection of this only. So let me fix this, that this line also passes through the intersection point, and let me. So this time we have this is 4a. This is the point where all the curve cuts themselves, and now this is the region that they have provided as net. So this is the region. Okay, that we need to find out. And now we have been provided with the limit of y. So I told you, whatever the limit you have been provided into variables, that is the strip that you have been given with. So we have limits of y, so we have vertical strip. This strip we have been provided with, and we need to change this into horizontal one. How would you change this? This way. And now you need to change the order of integration. How would you change? Since you want to change x into function of y and y as a constant. So how would you change? You have to take now horizontal strip and take this horizontal strip till here, because this is the horizontal strip and we need to find out this area. So if I am move this horizontal strip up and down, then it would curve the between y is equal to 0 to 4. This is 4a na, so this point is 4a, 0, 4a. If I move this horizontal from here to here, then it would cut the entire region of this. That is, if I revolve 0 less than y less than 4a, so we would get this entire region, right? This horizontal strip would give us entire region, but we need this much only. So how would you cut these, and how would you write these limits? Because these limits would be fixed by x na. So x would go from this line to this line. This is the limit for a horizontal strip, and this is the maximum height that it would go on the y-axis. So y would ranges from 0 to 4a, and now we need to fix the limits of x. So limit of x would be this limit would be fixed by this side from this equation, and this equation is for y square is equal to 4ax. So from here we get x is equal to y square by 4a. So from here to here we need to go, and this limit becomes y square by 4a. Again, this limit is given by this curve, and this curve is x square is equal to 4ay. That means x is equal to under the root 4ay, that is 2 root ay, and hence we have upper limit as 2ay. And these are the limits which we required, and these are the limits which are changed. So now we can calculate this integration by using the principle of change of order of integration, and this becomes, now we have changed limit, inside we have limits of, now we have limits of x, and outside we have limits of y. Since y ranges from 0 to 4a, so this would be 0 to 4a, and inside we have limits of x which are from y square by 4a to 2 under root ay, y square by 4a 2 under the root ay, and inside first we were provided with dy dx, and now we have changed these limits, so it would become dx dy. Now you just calculate this integral, and this integral becomes 0 to 4a. What is this? This is nothing but 1, and if I integrate with this with respect to x, so it would be x, and the limits, upper limit is 2 root ay, and lower limit is y square by 4a. dy is the remaining. Then it is 0 to 4a, and it becomes 2 root ay minus y square by 4a integral with respect to y. So it becomes, now we have 2 root a, it can be taken outside, it would be root y. I can write this way. So how would you integrate? This is y raised to power half 2, adding 1 of the power, adding 1 to the power and then dividing by the same. So we have already half power and it would be 3 by 2 divided by 3 by 2 minus this would be y cube by 3 into 4, that is 12a, and limit is 0 to 4a. So this becomes 4 by 3 root a and then 4a raised to power 3 by 2, that is, can I write it this as 2 root a, its square, and then power 3 by 2, so that we can cut the power 2 by half, and this would be 4a cube divided by 12a. So this becomes 4 by 3 and we have 2 would be cancelled out. So 2 raised to power 3, that is 8, and then we have 3 by 2 and half outside. So this becomes a square minus, from here we get 4, that is 64 by 12, and upper side we have a cubed by a, so a square. So this would be cut by 3, that is 3, and 4, 1 and 6, 16 by 3. This is 8 into 4, that is 32 a square by 3 minus 16 a square by 3, that is nothing but 16 a square by 3. So this is the answer. So the procedure is, first you have to draw the region which is bounded by the limits, that is upper limit as well as lower limit, and after that if you are provided with the horizontal strip, then change into vertical one, and if you have vertical strip, then change into horizontal one. So this was the thing, that how we have changed. We have drawn the region from here, this turns out to be both the parabola, and then horizontal, we were provided with the vertical strip and we have taken this to horizontal strip. Next example, this was the simple thing, that only we had only one type of curve on both the side. Sometimes what happens, from going one place to other, the curve changes, and let me take some of the example of that kind so that you don't face any of the problem while solving such kind of question. So the question, let me write first, then we will start. The question says that change the order of integration in integral I, which is given by integral 0 to 1, and then we have x square to 2 minus x, xy, dx, dy, and hence evaluate the shape. That is, you are asked first to change the order of integration, and after that you need to solve this integral. How would you change the order of integration? I told you, first write the limits, then draw the region. So limits here are 0 less than, see, how would you recognize? Since it is a function of x, so these are limits of y, and the other limit which is constant is limit of x. So limit of x ranges from 0 to 1, and then you have y ranges from, lower limit is x square and upper limit is 2 minus x. So our first task is to draw this region. So upper one is constant, so that is very easy to draw, and we will draw this here. They are saying x is equal to 0 to x is equal to 1. So this is x is equal to 0 line, that is y axis again, and this is x is equal to 1. After that, we will try to draw the second region, and second region gives us two equations, that is y is equal to x square and y is equal to x minus 2. Y is equal to x square, or we can write this as x square is equal to y. Now we know this is one of the parabola, x square is equal to y, and this is upper one parabola na, x square, that is even power of x, so it is, the curve would be symmetric about y axis, so it would be upper one and it passes through 0, 0. So the parabola would be this one, but first we will find out. This is x plus y and equal to 2. This is a equation of line. So this equation of line, first we will find out the intersection of both these curve as well as intersection with coordinate axis, so that we can draw accordingly. If I write y is equal to, from here I can put y equal to this side, so it would be x square is equal to x minus 2, and it is x square minus x plus 2. This is equal to 0. What are the roots of this equation? Product should be 2, sum should be minus 1. Can I write x square minus 2x plus 1 x? This is not the thing. At this time product would be minus 2, or we should have x, product should be minus 2 only. So how would you find out? At x is equal to 1, 1, let's first find out the coordinate axis of this. If x is equal to 0, then y is equal to 2. So at x-axis it cuts at y-axis it cuts at 0, 2, and at x-axis it cuts at 2, 0. So these points would be somewhere here. At x-axis it cuts at 2, 0. This is 1, 0 na? 1, 0. And at y-axis it would be somewhere here, that is 0, 2. So the line becomes this way, right? And next we need to find out other parabola is this way. How would you find out this point, whether that is on the same point or not? First we would find out whether the line x is equal to a cuts this parabola at which point. If I put x is equal to 1, then from here we get y is equal to 1. So the point is 1, 1. And this is nothing but 1, 1 point na? 1, 1. Because I got y is equal to 1 on this line. So the line is x plus y is equal to 2. If I put x is equal to 1, then we get y is equal to 1 only, plus 1, and y is equal to 1. So all the three curves are here. So our region of integration should be inside this, below this, as well as above this. So the required region is this one. So this is the region that we need to find out, or this is the area which we need to find out. Or so how would you find out this? Let me write first. This was the region, and then we had the line x plus y is equal to 2. Now we have drawn the region, but they have provided us y limit. That means we are provided with the vertical strip this time, and this is the vertical strip. But for changing the order of integration, we need to make this horizontal. And how would you make this horizontal? Draw a strip here. And tell me, if I draw a strip here, then this, if I move this strip down and upwards and downwards, then wouldn't there change of curve? If I move from here to here, then we have on the downside this curve, but on the upper portion we have this curve na. So there is change of curve in this question. From here to here we go use this curve, and then we need to go along this curve. So what will we do? We will draw a line from this change of curve, the point from where the curve changes. Okay, this is the boundary, and now we need to fix the limits. Since y ranges from 0 to, this is point 0, 0, and that point is 0, 2. So y runs from 0 to 2, but the value of x would be limited by, on this side it is x is equal to 0, but when we come to this side, then first we have this line and second we have this line. So accordingly we have to break y also in these points, and this is which point? This point is 0, 1, because this is 1, 1, so it would be 0, 1. On the y-axis, x is always 0, so this is 0, 1. So our limit would become How would you write the limit? First you have to write y from x would be running from there to there, and y runs first. Then we will write this. We have to break this area into two intervals or two integrals or two areas. Can I write name? Can I name this? If this is O, that is origin. Then if this is A, I can say this is B and C. Then our integral I would be broken into two integrals over two regions. Now, first region is OAB, OAB, and second region is ABC. And this was xy dx dy plus xy dx dy. But we are going to change the region, not change the region, change the order. So this would become dy by dx, and this would also become dy by dx, and we will change the limit accordingly in the next step. This is dy dx. And how would you change? In the region, tell me now, in the region OAB, you are provided with x outside. Now you need to write y outside. So here we should have limits of y, here we should have limits of x. Right this way if you are getting confused. So limits of y in this region OAB, they are from 0 to 1. Y runs from 0 to 1, and then you need to find out the limits of x. On this line x is always 0, and on this line x is restricted by, this is which curve? X square is equal to y, but we need limit of x now. So it would be x is equal to root y. So x runs from 0 to root y, and inside we have the function xy dy by dx plus double integral. Now we have to write the limits over the region A, B, C. So in this region y runs from 1 to 2. Now limits of y have changed because this time y is from here to here. That is, y runs from 1 to 2, and x also changes. On the left side we have x is equal to 0, but on the right side we have this line. Limits of x are restricted by this line, and this line has equation x plus y is equal to 2. So we need limits of x, and x is nothing but 2 minus y. So upper limit of x is 2 minus y, and inside we have this function xy dy over dx. Right? So this becomes, now you can calculate these integrals. And how would you calculate? First we have inside the limit of x, so we will integrate this with respect to x. And if I am integrating this with respect to x, x, then it would be nothing but x square by 2, y is treated as constant, y outside, and then we are left with what are the limits? 0 to root y, and we have limit dx. Plus, similarly we will calculate this one, that is y is equal to 1 to 2, and here also this would be y outside, then x square by 2, and this time we have limit 0 to 2 minus y, and remaining thing is dy. This was also dy. We have integrated with respect to x. So by putting values of y, we are getting I is equal to integral 0 to 1, y is left. Then if I put root y, that would be y raised to power nothing but y, that total becomes y square by 2, and we have dy. 0 would be 0 plus second 1 to 2. If I put x square is equal to 2 minus y, so it becomes y, that is 2 minus y whole square, that would be 4 plus y square minus 4y divided by 2, and this is y. Let me write on the next page. It becomes I is equal to under the root 0 to 1 y square by 2 dy. Let me check if it was right or not. This limit is 0 to 2, 1 to 2, y square by 2 dy. Then we have y into, can I multiply y inside? 4y y cube minus 4y square. 1 by 2 outside. 4y minus plus y cube minus 4y square, if that was the correct thing, or it was 4y. Yes, 4y plus y cube minus 4y square and dy. So these were the integrals, and it becomes y cube by 6 0 to 1 plus half, that is 4y square by 2 plus y4 by 4 minus 4y cube by 3, and that was half outside 1 to 2. So it becomes 1 by 6 plus half 2 into 4 minus 1 plus 1 by 4 as it is, then 2 raised to power, that is 16 minus 1 plus 4 into 2 cube, that is 8 minus 1 by 3, and in total we have 1 by 6 plus 1 by 2. This is 3 into 2, that is 6 plus 15 by 4 plus 7 into 4, 28 by 3. This becomes 1 by 6, and LCM of this is 12. This 12 into 6, that is 72 plus 3 into 15, 45 plus 28 into 4, that would be 4, 8, 3, 2 and 4, 8, 32, 3 would be carried, and then 4, 8, 11. So this becomes 1 by 6 plus half. The sum becomes 2, 5 and 7, 9. Then 1, 4, 5 and 7, 12. And then we have 1 only, and that is 2 divided by 12. So calculate these values if anything becomes. So answer should come 3 by 8. And if it is, then okay. Otherwise check the calculations. It should turns out to be 3 by 8. Okay, so this is how you need to do change in the order of integration. That first one was the simple one where we were having only single curve on the both the side, and in the second one we have change of the curves. Curves are also changing, so you have to break the limits of y, and if there is change in the curve on the other direction, then you have to break the limits of x. So you will decide which limit you need to break, and accordingly you have to adjust. Please guys check the calculation. It may not be correct, but this is the procedure. Okay, that was it for the today's topic. Thank you.